Dr. Elakpa is the head of research and development at Somatrix Marine Limited, a premier maritime engineering firm specializing in advancing naval architecture, marine asset integrity, and surveillance solutions. With extensive expertise in structural diagnostics and marine engineering, Dr. Augustine champions integration of next-generation technologies into traditional maritime frameworks. At Somatrix, he leads pioneering initiatives in advanced non-destructive testing, underwater inspection, robotic hull scanning. His work focuses on transforming raw physical survey data into dynamic digital twins and actionable predictive insight. Dr. Elakpa collaborates closely with leading academic hubs, including Rivers University, to drive data-driven fleet reliability and predictive maintenance strategies across West Africa and the maritime corridor. Okay, Dr. Elakpa Augustine, I'll say the floor is yours.
Thank you for the opportunity to tell you a little bit about marine survey and inspection and what we do at Somatrix and about inspection in general. This I noticed that most of the participants have talked about types of inspection, a couple of times, going from reactive, preventive, maintenance inspections. But ours, in this case, we are more concerned with marine inspection, particularly about vessels, right? And also floating and offshore structures, floating and fixed offshore structures. But for this particular case scenario, we just look at marine structures in terms of vessels primarily at this point. So our agenda will just based on the maritime assets. Yeah. We'll look at the marine asset challenges, look at survey and smart inspection. We'll look at inspection technology stacks, which are ROV, remote sensing. We'll go to data-driven predictive analysis, which is part of the whole presentation, digital twin integration, and what we'll do at Somatrix in terms of the framework and the ROI. So traditional inspection usually is periodic, it's timely, it's manual. Sometimes there are lots of paperwork and also some sort of stacked booklets to tick, and all of that. But these days, with the idea of digital transformation and also moving fast to the digital age, we're also looking at incorporating a lot of smart technologies these days. So amongst them are digital twin integration, real-time and decision-making, and also some preventive scheduling that are well automated, amongst others. So the special technologies we are leveraging and we are trying to work with non-destructive testing, maintenance, which has to do with ultrasonic testing. Sometimes most of these technologies we employ here are also driven by the need from our third-party customers most of the time. So we also look at IoT condition monitoring, digital twin, where we have a digital copy of the structure we are looking at or the facility we are looking at and trying to reproduce, although it can be quite engaging because you have to look at the various components you're actually interested in monitoring and also create the digital copy and the whole integration of sensor-driven part of it. And also, of course, these days, a lot of people are incorporating artificial intelligence into most of their models to ensure proper predictability and reliability in terms of making decisions. So we're also looking at leveraging on some of those concepts as well, so that we're also moving with the train and what's really involved. So we also look at structural health monitoring. One of the major part of marine survey, especially for vessels, the whole structural integrity, which brings us to the condition monitoring. Yeah. So structural integrity is very important for us. Look at the hull and also all the other structural components of the hull. Also look at machinery monitoring. Most of you will be talking about rotating equipment. We also look at some of these things also in the maritime industry, particularly we have a lot of pumps. We have some machinery, some main and small auxiliary engines moving. We have purifiers, coolers, and all sort of rotating equipment also on board vessels. Of course, we also look at corrosion, what it does to this equipment, and also try to look at them. And of course, when there are a lot of cyclic loads every now and then, because this equipment, they work over time, from time to time, the tendency for them to have some fatiguing tendencies are also there. So we'll look at most of these things. And then we have our monitoring data flow, where we'll get data from the sensors, and then we process them through the edge cloud, and then get some automated reports. So our data-driven concept here is getting data from the sensors and applying some feature engineering concept to them, like corrosion variables, fatigue variables, vibration signatures, which is not really a core thing. Then integration trends, which leads to different types of corrosion and also inspection as well. And this data can also help you with the different models you need to employ, and you pick the best model. And then this best model helps you with generating, or what I say, coming up with actionable things to do so as to avoid future occurrences. Digital twin application is a technology that is fast evolving these days. Sorry. And it has really helped respect to inspection jobs, where you look at real-time structural load mapping and also corrosion simulation, structural model synchronization, and also maintenance scenario planning. And this has actually reduced unplanned downtime and decreased survey inspections, and also has also helped with detection of responses 2 times faster. Of course, these days with the digital concepts, even owners can even monitor real time how their vessels or their structures or assets, as the case may be, also undergo real time degradation. And so, also integrating this into our framework, we have four pillars of it. We have the survey intelligence part, the digital inspection, the condition analytics, and reporting. This has also been discussed, slightly in the previous slides, where under the pillar section, we look at classification, society, liaison. Of course, we don't just work individually; we also work with class and also state, and also state flag state. For example, the flag state we have in the country here is NIMASA. So work with them. We also work with different prioritization. Then on the digital inspection parts, we have our real-time logging systems, and also on condition monitoring. There are a couple of them there: structural health monitoring integration, degradation trend modeling, predictive alert generation, and prediction of area remaining useful life estimation. And on integration, also there are regulatory grid documentation, defect tracking, risk rank action, and also historical audit trail. So these are some challenges an application with a Nigerian fleet. And some of the challenges we've encountered are H fleets with no digital inspection. Of course, most of the vessels that operate here, some of them are vessels who come from other parts of the world with no proper documented detail. So it takes time to start creating all of this from scratch, and most of them are very old vessels. Also, the high corrosion in our region because of the water, and also sometimes our flag state, which is NIMASA, have a problem with implementation, and also dry docking issues, which are not really that much. And also the accessibility to this data is also highly limited. So at Somatrix, what we do, we try to create some sort of baseline ROV scan. We also try to increase some of this smart solution with this digital application, and it has actually given a lot of good outputs where we have, of course, a lot of reduced time unplanned events, and also it has even helped with improving some of the flag state inspections that we've done for some of our clients lately. And also fleet downtime have reduced drastically to around 20%. And also a very robust framework for established digital audit. Also, our ROI on business from reactive maintenance we've done so far, we've seen that it's really high, and with preventive maintenance, it has dropped to about 52, and also the predictive maintenance really dropped to about 28%, which gives us around 3-to-1 ratio of average return on inspection, with about 60% dry docking events and 40% potential reduction in issuance and less than 2 years payback period for digital program. So what are the key takeaways? The periodic survey, shift from periodic surveys to continuous data-driven survey is very competitive and safe, and safely imperative. So it's not just a trend for Nigeria, it's something that is really, really global these days. Few months ago, we were in Singapore for the Singapore Maritime Week, and you come to see there are a lot of solutions these days that are going digital. And why are they going digital? Because of their ease to use, and also the availability of data, and with the trend of artificial intelligence, which brings us to takeaway number 2, where we employ a lot of IoT sensors and AI analytics solutions that are easily deployable also even to local environments, and also with the intention to scale up. So also, it also reduces downtime. We know all of that already from every predictive maintenance approach, that downtime is usually reduced a lot. And also, our workflow has also helped with certifying local flag state requirements like we have in NIMASA in Nigeria. So Somatrix also has a 4-pillar framework, which I already presented earlier on, and it has been effective for us. And we're also looking to improve this framework. And also, digital transformation starts with a vessel, and then we take it around sensors into other vessels as well. Thank you very much.